So electricity and magnetism pop quiz 4, which was related to the circuit components as we discussed. The diagram shows a potential divider. What is the meaning of a potential divider circuit? When two or more resistors are connected in series, we call them as a potential divider circuit. And what is the concept of a potential divider circuit? Why we call them as a potential divider circuits? Because the voltage will divide between the component. Like if I have a 10-volt supply, if they have the equal resistance, then the voltage will divide equally. So this will be 5 volt, this will be 5 volt. But if they have unequal resistance, like example, if one of the component is having a high resistance than the other, so the one which is having a high resistance, there will be more voltage drop. So out of 10, maybe 7 volts here, so remaining 3 volts here. And if we change the combination of the resistance, like one side we have more resistance, other side less, so the voltage division will also change. The resistance of a variable resistor decrease. So this is a variable resistor and we reduce the resistance. So if we decrease the resistance, what happened to a voltage or a potential across this? That will decrease. So the reading on the voltmeter P will decrease. And because it's a potential divider circuit, so what happened in a potential divider circuit? That if one side the voltage decrease, the other side the voltage should increase. Because the sum of the voltage should be same. So if the reading on the voltmeter P is decreasing, what happened to the reading on voltmeter Q? That should increase. So if they were having an equal resistance, voltage will divide equally. But if the resistance of one component is decreasing, so the voltage across that component will decrease and the remaining voltage will be the across the other ones. That will increase. That's why B is the right answer for this. After some building work in a house, a bare uninsulated wire, a live wire is left protruding from the wall, like touching the wall. What is the greatest hazard? What is the greatest hazard for a live wire to be uninsulated? Like if someone will touch, he will get an electric shock. That's why there's an insulation on the wire. In which circuit does the ammeter shows the greatest reading? How we know which circuit the ammeter shows the greatest reading? The circuit which allow the maximum amount of current to pass and which is having the least resistance. So if you check like this is plus and positive and negative, conventional current will move. So this will allow the current to pass and the other will also allow the current to pass. So as a result, both will allow the current to pass. So there will be a maximum current in the circuit. Why not other? Like why not B? Because this will block the current and this will only allow 3 ohm will allow. Here what will happen? 2 ohm will block, like the two diodes will block, and here this will allow the current to pass, the other will block. So the maximum current will flow through circuit diode. And when two resistors are connected in parallel, the combined resistance of a circuit is low, so the current will be high. The diagram shows the circuit, electrical circuit. The light falls on a light dependent resistor, increase in the brightness. So what is the effect? This is a LDR. So if the light intensity increases, more light is there, so resistance of LDR will decrease. If the resistance of LDR decrease, so voltage across LDR will decrease. And if voltage across LDR will decrease, the voltage across the fixed resistor will increase, or the reading on the voltmeter will also increase. So what happened to the resistance of LDR? The resistance of LDR should decrease. And what about the current? Because if the resistance is decreasing, the current in the circuit will increase. And what about the reading of the voltmeter? Voltmeter is not parallel to LDR. Voltmeter is parallel to a fixed resistor. So if there is more voltage across the fixed resistor, the reading on the voltmeter will increase. So it will be decrease, increase, increase. That's why B should be the right answer. In question 5, the diagram shows a circuit. When switch S is closed, closed means like we connect. So the conventional current will move. First, this diode will allow, then this diode will allow. So which lamp will be on? Only lamp 1 will be switched on. That's why A is the right answer for this. Because when the current is passing through this side, this diode will allow. But if it is from the wall, the diode will block. Diode is used as a rectifier. These allow the current to move only in one direction. A student sets up a circuit containing a battery, 2 cells, and 3 lamps are there. Which diagram shows this arrangement? First, we have two cells are there, so my negative, positive, and then negative, positive. Then there is one lamp after that. This lamp is there. And with this lamp, they're connected another lamp. And these two lamps are in parallel, one over the other. And then the circuit complete. So which one it match with? Like 2 of the lamps should be parallel and 1 lamp should be in series. So it matches with option A. Like this matches with a circuit diagram. So 1 lamp is in series, like this lamp is in series to a 2 parallel combination, 2 parallel, and then the circuit completed. B means 2 lamps in series, like it should be like this. 2 lamps connected, one next to the other. And then with that, another lamp is connected. But according to the diagram, we have 1 lamp and next to this lamp, there are 2 lamps which are in parallel. That's why A is the right answer. In which circuit does a lamp light? So conventional current from positive to negative. So when we show the conventional current, this will allow, but this block, this also block. When we check the conventional current, this block, this will also block. When we check the conventional current, this diodes will allow and the circuit will be complete, so the lamp will light up. Here, the first diode allow, but the second will block, so the lamp will remain off. So when the current is from the side of the play, the diode will allow. When the current is from the side of the pause, the diode will block. Each potential divider circuit, potential divider means like when 2 or more components are connected in series, we call potential divider circuits. And which potential divider makes the potential difference across the component Y increases with a light intensity increase? First, C and D cannot be an answer because C and D are using thermistor. So it cannot be an answer. Either A can be an answer or B. Now, when we check the options, if the light intensity increase, so if the light intensity increase, what happened to resistance of LDR? The resistance of LDR will decrease. If the resistance of LDR is decreasing, what happened to voltage across LDR? That will also decrease. And what happened to voltage across the fixed resistor? Because in a potential divider circuits, if one component, the voltage decreases, the other component voltage will increase. And we want in the question, the component, we want the potential across Y to increase. So A is the right answer. What happened in B? As the light intensity increase, the resistance will decrease. So voltage here will decrease. And in comparison, voltage across X will increase. So we want the voltage across Y to increase, not X. That's why B is not the right answer. So potential divider circuits, if one component resistance decrease, the other component resistance increase and the voltage will increase. A cell is connected in parallel to a combination of 2 ohm and 4 ohm. The current in 4 ohm is 1 ampere. What is the current in the cell? Means we need the total current. How we can work out the total current here? Because if they are connected in parallel, it means they will have the same voltage. Like what is the voltage across the 4 ohms? The same voltage will be there across the 2 ohm. So we can work out the voltage across 4 ohm. V is equals to IR, where I is the current, 1 and resistance is 4. So that is equals to 4 volts. So if this is 4 volt, what voltage will be here? 4 volts. Because they are in parallel, they will have the same voltage. If we know the voltage, what will be the current here? So we again use the same formula, V equals IR. So voltage is 4 here, current we don't know, and the resistance is 2. 2 is multiplied, other side will be divided. So 4 divided by 2, that is equals to 2 ampere. So means the current of 2 ampere from this one and the current of 1 ampere is in a 4 ohm. The question is, what is the current in the cell? So what is the total current enter from the cell? If 2 ampere is passing through 2 ohm and 1 ampere is passing through 4 ohm, so the current from the cell is 3 ampere, which is 2 plus 1. So total current is 3 ampere, which will divide 2 ampere across the first branch and 1 ampere across the second branch, through the second branch. So first we use a formula to work out the voltage across 4 ohm, and that voltage will be same as the voltage across the 2 ohm. We get the current in 2 ohm and then we just add to get the total current. In question 10, four circuits are shown, all include an AC power supply. When in a question you have AC power supply, the positive and negative terminals are not fixed. You have to check both. The question is, in which circuit is the rectified current? Rectified current means like current is moving only in one direction. So first this is positive and negative. So the current cannot move, like this diode will block. Then this is positive and negative. The current will move through first diode. Then the current will move through second diode. So it will allow the current to pass. So one way the current is passing, another way the current is not passing. So A is the right answer. Why not B? When we check for B, positive and negative. So when the current will move, this diode will allow. So what is the direction of the current in this way? And if we check the other way around, so this diode will allow for direction of the current in this way. So means in B, the current can move in both ways. Like the circuit allow the current to flow in both ways. But we want a rectified current. The term rectified means we want a current to move in one direction. Why not C? If this is positive and negative, so this will block. So there is no current. And if this is positive and negative, this will also block. So there is no current. If for D, if this is positive, first diode allow, but the second will block. And right hand side positive, left hand side negative. So this will allow and the second will block. So means the D, C and D, there is no complete circuit. That's why option A is the right answer for this. The diagram shows a part of circuit used to switch the street lamps on and off automatically. In the evening, this is an LDR, light dependent resistor. So in the evening, it get dark. So if it get dark, what happened to the resistance of LDR? It will increase. If the resistance of LDR will increase, what happened to the voltage across LDR will increase and voltage across the fixed resistor will decrease. So potential resistance of LDR, if it get dark, resistance of LDR should increase and the voltage across LDR should also increase. So increase, that is matched with option D. A student connects a variable potential divider or a potentiometer. What happened to the reading of voltmeter as a what happened to the reading of the voltmeter as a sliding contact is moved from R to S? Look, when the sliding contact is at position R or near R, this will have this part will have a shorter length and this part is having a longer length. So if the length is shorter, it means that part will have a low resistance. If that part is having a low resistance, so what will happen to a voltage here? It will be less or small voltage. But as we move the sliding contact from R to S, so as this sliding contact is moved, what will happen? Like if example, if you have a sliding contact at this point, so now this part will have a greater resistance. This part will have a long, because greater length is there, so it will have a greater resistance. So if this part is having a greater resistance, what happened to a voltage across this part? That will also increase. So the voltage divide depends on the part of the component we are using. If we have like, if it is equal, if you have a 12 volt supply, when this sliding contact was near the top, or say the sliding contact was exactly in the center, this will be 6 volt, this will be 6 volt. But if we were having a sliding contact near the top, so this part does not have any resistance, so that will be 0 volts. This will be 0 volt and this 12 volt. And if we slide it down, the sliding contact near the bottom, so this will have 12 volt and this will have 0 volt. But the total sum of the voltage should be 12 because we are using a 12 volt supply. So the question is, what happened to the reading of a voltmeter as a sliding terminal is moved from R to S? So first it was R, like near the R, so it will have 0 volt. Then it moved to S, so it will be 12 volt. So the reading will increase from 0 to 12. So whenever we move the sliding contact, the part which is having a low, like less resistance or a shorter length will have less voltage across it. And the part which is having a greater length will have more voltage across it. The diagram shows a circuit with an AC supply. How the current of a resistance vary. If we have an AC supply, like first this is positive and negative, so the diode will allow the current to pass. So it allow the current to pass. So this is allowing the current to pass. This also allow the current to pass. This also allow the current to pass. But when it changes the terminal, because it's an AC supply, so this will be positive and negative. So diode will block. Diode does not allow current. But here what it shows it allow the current in opposite direction. So it cannot be A. It cannot be D because it shows it allow the current in the same direction. So it cannot be D. It should be B because like what it shows that diode first allow the current to pass and then it does not allow the current to pass. So current will be 0. Then again, what will happen? This will be positive and negative. So the diode will allow the current to pass. So current will pass. Then when it changes the terminal, the diode will block. So one way diode allow, then block, allow, block, allow, block. So this is how the output will look when we have a single diode in the circuit. Like because one way, if we have AC supply and a single diode in the circuit, so one way it allow and the other way it block. So B should be the right answer for this. The light dependent resistor and a resistors are connected in series. So this is again a potential divider circuit or a voltage divider circuit. The brightness of a light falling on the LDR will decrease. If the LDR, the brightness decrease, so its resistance will increase. If the resistance increase, what happened to the voltage across LDR will increase. And what happened to voltage across the fixed resistor because they are connected in series, or it is also a potential divider circuit. So in series, if one component receive more voltage, if the total is constant, if voltage across one component is increasing, the voltage across the other component will decrease. So the voltage, the resistance of LDR, what will happen to the resistance of LDR? The resistance of LDR should increase. And what about the reading on the ammeter? Because the resistance, this is a constant resistance and the LDR resistance is increasing. So what happened to the amount of a current which is flowing through the ammeter, that will decrease. So LDR resistance will increase and the current will decrease. So for 14, C should be the right answer. In question 25, which electrical symbol represents a diode? A is representing a cell, B is representing a diode, C is representing a lamp, and D is representing a variable resistor. You have to learn these circuit symbols. So B is the right answer here. The student set up the circuit. What is the purpose of the circuit? In a circuit, when you see a thermistor, means it should be in a temperature sensing circuit. Allow the lamp to make dimmer or brighter as required? No. If we want to do this, then what should be the component here? For that, we need a variable resistor. If we want to change the brightness of a lamp by ourselves. Amplify the sound. It does not have any sound detecting. It sound producing equipment is there, but not sound detecting. To light a lamp in dark, it does not have LDR. If it was having LDR, then it will use to light up. To sound a bell when the temperature rise, because what will happen when the temperature will rise, the resistance of thermistor will decrease. If resistance of thermistor will decrease, the voltage across the thermistor will also decrease. And because in comparison, the voltage across the bell will increase, so that it will ring louder. Because they are connected in series, so one component, the voltage is decreasing, the other component voltage will increase. This is a potential divider circuit. The diagram shows a voltmeter P and Q. The sliding contact at point X is moved towards the top. Like when it is exactly at the center, they will have the same voltage. But now this sliding contact is moved towards the top. So what happened? Resistance of that part will be less. So voltage across this one will be lower. So voltage across the voltmeter P will be less. And in comparison, this will have greater length or more resistance or more voltage. So the reading on the voltmeter Q will increase. So voltmeter P reading will decrease and the voltmeter Q reading will increase. So it will be B, decrease and increase. Next is question 18. A lamp is to be connected in a circuit so that the potential across the lamp can be varied, like we can change the voltage across the lamp, which is the most suitable circuit. Here, if you see, the lamp is connected in parallel to the battery, so it will always receive 6 volt. We cannot change. When you check B, like if we have a 6 volt supply and this is a variable resistor, so if this part is having a shorter length, so maybe 2 volts here and 4 volts here. And we can change this voltage. How we can change the voltage? By moving a sliding contact. If I move this sliding contact down, the voltage across the lamp will decrease and the voltage across the top part will increase. So by moving the sliding contact anywhere, we can simply change the voltage across the lamp. That's why B is the right answer. Why not C? Again, you can see C, the lamp is directly connected in parallel to the supply. So the voltage cannot be changed. It will always receive the same 6 volts. But here, the lamp is not directly, like first what we have variable resistor, this part, and with a part of a variable resistor, a lamp is connected. So the voltage will divide between, like if it's a 6 volt supply, 2 volts here, 4 volts here. And if we move the sliding contact down, the voltage down will be less and voltage at the top will be higher. So again, a similar question, we are using a diode. Whenever a diode is used, a single diode with the AC supply, we just did that. One way the diode will allow the current to pass and other way it block. So that's why C should be the right answer. Because from AC supply, the diode is used as a rectifier, which allow the current to move in one way and it block the current other way around. So the voltage graph will be same as the current graph. First, the voltage will be like one way it allow, the other way it block. So that other cycle, the voltage will be 0. The diagram shows a circuit containing a battery resistor with a high resistance, switch and a lamp. Initially, the switch is open. What happened to a lamp when the switch is closed? Look, when we close this switch, it will be a short circuit. What is meaning of a short circuit? Means the electric current will flow through a least resistive path. So it will not flow through a resistor, it will flow through a switch. And lamp will receive all the voltage. There will be no voltage across the resistor because it's like the circuit is bypassed, like the resistor is bypassed in the circuit. Resistor is not a component of the circuit. If there were two resistors, like example, we were having two resistors and there was a switch and a lamp. And in that circuit, if we close this switch, then the current will flow through both of them. Like there will be a current in the first resistor and the current in the second resistor. Why? Because both passages have the resistance, so the current will flow through both of them, each of them. But when we close, we have only switch here, no other component. So all the current will flow through the switch and there is no current in the resistor. So resistor won't be a part of the circuit, or this circuit is known as short circuit. So when we have a short circuit, all the energy is received by the lamp. So as a result, this lamp will grow brightly. In question 21, again a similar question. Whenever a diode and AC supply is there, the diode is used to rectify or allow the current to flow in one way and block the direction of the current other way around. How we know it is a short circuit? If you have only one passage, like you don't have any other component in the circuit, when you close this switch, so now there is no other component in this passage. When you don't have any component in the passage, that is called a short circuit. So the circuit is short when you close the switch. And when we say a circuit is short, it means some of the components are not part of the circuit. If there was any component here, a resistor or a lamp or any device, any component, then it won't be a short circuit. Short circuit means like circuit without any resistance or with a very low resistance. Temperature, how the temperature affects the resistance of a thermistor. If the temperature is decreasing, if a temperature is decreasing, what happened to resistance of thermistor? It should increase. If the resistance of a thermistor is increasing, what happened to the current in the circuit? The current in the circuit should decrease. So if a temperature is decreasing, the resistance should increase. So this is wrong. If a temperature is decreasing, the resistance should increase and the current in the circuit should decrease. Because if the circuit is having a high resistance, it does not allow greater amount of charges to flow through it. So when the temperature decreases, the resistance of thermistor increase, the charges are not able to flow through the circuit as the flow of the charges decrease. Question 23, the circuit diagram shows a fixed resistor and a thermistor, which is used as a potential divider. What happened to VR when the temperature is decreasing? If we decrease the temperature, so if we decrease the temperature here, what happened to resistance of thermistor? It will increase. If resistance of thermistor will increase, the voltage across the thermistor will increase or VT will increase, and in comparison, voltage across the resistor will decrease. So voltage across resistor should decrease and the voltage across thermistor should increase. That's why A should be the right answer. Question 24. The circuit shows a power supply connected to some circuit components. In the diagram, P and Q are the terminals of a DC supply. So we have a DC supply. Now we have to underline which circumstances the ammeter shows reading other than zero. Like ammeter will show any reading but not zero. When P is positive, so if P is positive, so the current will flow, some of the current will flow through this one and some will flow through R2. So the ammeter will show other than zero. Like there will be some reading on the ammeter. So first one, if P is positive, there will be reading. But if P is negative, Like if P is negative, Q is positive, so the current will flow. But when the current flow, this will block. So as this diode will not allow the current to flow. So what is the reading on ammeter? The reading on the ammeter is 0. So when P is positive, the ammeter shows non-zero. But when P is negative, the ammeter shows 0. So it cannot be A. When we check B, the ammeter always shows a 0 reading. Like if P is positive or negative. No, that's not correct. It will only when P is negative. So what will happen when P is negative? Because the question is under which circumstances the ammeter shows a reading other than 0. Like ammeter should not show 0. So what will happen when P is positive? This will allow the current to pass. And this will also allow the current to pass. So only when P is so only when the P is negative, for example, if P is negative and Q is positive, the ammeter reading will be 0. But when P is positive, the ammeter will show other than 0. And the last one, in which circuit a single lamp lit. So if this is positive and negative, the current will flow through this lamp and the current will flow through this. So both lamp will light up. In this one, it blocked the current, so there is no lamp lighter. In C, this will block, so this lamp, so C is the right answer. And in D, it completely blocked. So this was a pop quiz which was related to circuit component.